Welcome back. This is Mr. Earlham. I'd now like to talk about, within the trigonometry unit, solving for missing angles. So far, we've been working with solving for missing sides, when we know the angle. But what if we had a triangle that was, for example, a 3, 4, 5 triangle, and we were curious as to what the angles are? I mean, we've talked about special right triangles, which are 30, 60, 90s, and this is a Pythagorean triple, so it seems like a special right triangle. Does it have unique, distinct, and easy to find angle measures? Well, let's find out. I'm going to call this angle x. We don't know what that angle is, so we don't know what its measure is. But relative to that angle, if I put my eyeball there, this 3 is on the opposite side. This 4 is adjacent, and this 5 is hypotenuse. And yes, I know that 5 is also adjacent to it, but it owns a special role in the sense that it's opposite the right angle. It's always the hypotenuse. So our question is then, which one is the adjacent leg? So relative to these, I want to find the value of x. I've actually got all three choices, so let's do it all three ways. If in fact I wanted to use the sine function, I know that sine falls under the SOH acronym, and therefore the sine of an angle is equal to the opposite over the hypotenuse. So in this case, the sine of x would equal to the opposite over the hypotenuse, so 3 over 5. If I were doing a cosine, on the other hand, I'd want to say that's a CAH, and the cosine of an angle is equal to the adjacent over the hypotenuse. And in this case, that would mean that the cosine of x would equal 4 over 5. And if I were interested in doing the tangent, I'd use TOA, and I'd say that the tangent of x would equal the opposite over the adjacent, so that'd be 3, opposite over adjacent, so the tangent of x would be 3 over 4. I can use any one of these expressions. They're all solved the same manner, just with different pieces. So for example, the sine of x is equal to 3 over 5. I want to solve for x. I want to get x all alone. So I ask myself, just as I do in any algebraic solving process, what's being done to x, so that I can undo it. If it had been 2 times x equals something, I'd divide by 2. If it had been x plus 6 equals something, I would subtract 6, because that undoes what's being done to x. So in this case, what's being done to x? And the answer is, it's being signed. Sign is a verb. It's not a number. It's something that does something to something else. You would sign the angle value of x. So if I want to undo something that's being signed, I need to unsign it. It's actually called inverse sine or arc sine. And if I do it to the left side, it effectively undoes this operation, leaving just x, and I'm left with just the inverse sine of that value of 3/5. Similarly, I would do the same thing over here. This says cosine of x equals 4/5. I want to undo what's being done to x. Right now it's being cosigned, so I would uncosine it, leaving me with just an x on the left-hand side, and I'd take the inverse cosine of 4/5 on the right-hand side. Similarly with a tangent, if I wanted to untangent it, I'd take the inverse tangent of both sides. These would cancel. I'd be left with x is equal to the inverse tangent of 3/4. And in all these cases, I've isolated x. It's by itself, which is what I want. So now it's up to the calculator. I'm going to take my calculator, and I'm going to enter in not the sine function, because that would take an angle and give it into a ratio. I want to take it from the ratio to the angle, so I press the second, which activates the yellow text here, which shows sine to the -1. It doesn't mean 1 over sine, as you might think it does. It means the inverse sine. So I'm going to do the inverse sine of 3 divided by 5, close the parentheses, and hit enter. And it gives me that x is about 36.86 869896765. This is the approximated value, but of course it could go on forever. This is just what my calculator was able to show me. Usually we'll be asked to round to something like the nearest hundredth, in which case I would say x is approximately equal to 36.8. And I'd look at the 100th digit, see if the number after makes it round up or round down. In this case, it would round up. So x is equal to 36.87. That was using the sine. If I had chosen to use the cosine instead, my operation would be identical. I'd simply say second cosine of 4 divided by 5, because now I'm using 4 and 5, and I'd get the same answer. Right? Because I'm finding the same value of x, and the tangent would do the same. If I said second tangent of 3 divided by 4, that would also yield the same value. So usually you actually won't be given all 3 sides. Usually you would be given just one pair of sides, and you have to choose which one to do. So for example, let's say I'm looking for this x value. I know that this is 5 and this is 12. We would say, all right, here's my eyeball up here next to the angle I'm looking for. Relative to that eyeball, this is my adjacent, this is my hypotenuse. Therefore, I'm dealing with A and H. I know that that's my CAH function, cosine. So that the cosine of x would equal the adjacent over the hypotenuse. So the cosine of our angle x is equal to 5 over 12. What is it that's being done to the x now? Well, it's being cosigned. So to undo that, I want to uncosine it. The inverse cosine to both sides. These cancel, leaving just x is the inverse cosine of 5/12, which I'll plug into my calculator and get that it's about 65.37568.165. Again, I'm going to round to the nearest 100. 65.37. The 7 is the one I care about. This is more than halfway, so I say 65.8. And that's how we use trigonometry to find missing angles. Thank you.